Okay, we're back, and we're going to start looking at making some of the enemies inside the Zool game. Now that we've done all the plumbing, we can actually start building some bad guys. So let's look and see what we need to do. First, we're going to start with the jelly object. I don't think we've created it yet. Look under hazards. No, he's not there. If we check our sprites, the jelly is right here. There's a jelly just going on a flat surface and then going up and down, and then the jelly dying. So those are the four sprites we're going to be looking at. So let's create the object to start with. So we do a create object, and we'll call this object jelly. And take a look for the sprite. Here's the first one. And here it's important to set the parent to object enemy. And remember, object enemy is a child of object hazard. So they all kind of line up. So we're looking at hazards, object enemy. So that's the first step. And then we'll add a create event. And notice as soon as we add our object jelly to as a child of object enemy, we get the two events that have already been defined for object enemy automatically. They're kind of grayed out here, but you can see that they already exist. So we have to create those again. But now we add a create event. So what do we do in this create event? Trying to add this box back to this one dialog, but it's just not doing it. Well, maybe that's a good thing. So the first thing we do is check to see if we're facing to the left. Why don't we do execute code? And we'll try this in GML today. Here's an execute code. We just drag that in to our workspace. It's not really working. Why not? We're in the create event. Here's there. Execute code. It's not dragging it in, is it? Hang on just a moment. So what I'll do is I'll just right click on it and say convert to GML. Say OK, and it just directly takes us there into code form. So first thing we want to check to see if object facing, or if the variable facing is set equal to face left. Okay. If that's the case, what are we going to do? Well, let's see. Yeah, we're not checking to see if it's set to face left. We are setting it to face left. So we're just assuming and it's going to start. And instead of using the equality operator, we use the assignment operator. And so we're just assuming that Zool is facing left for some reason on the jelly. Now the jelly really doesn't have a facing. I guess it's moving in a direction, and so maybe the facing tells you which direction it's moving. So we're going to assume that that he's moving to the left. Now we're going to add a step event that's here. Oh, our window's back. That's interesting. I think I closed it and then finally it reappeared back on this window. Very strange windowing system. So we're going to set the horizontal speed to facing times 1.5. So let's convert this to GML. Just go straight into GML. We'll say h speed. We just have to click in the box there. H speed, which is your horizontal speed, equals facing times, get the right, no, that one, nope. My keyboard's hard to see, so times 1.5. So I'm looking at this facing variable, and let's not get it confused with the facing variable that's on Object Zool. It has its own facing variable. This one is just unique to the jelly. So this would be considered a local instance variable in fancy object-oriented computer speak. And so we're going to set the speed to, now facing is either has a value of -1 for face left and +1 for face right. So your speed, horizontal speeds are going to be +1.5 going to the right or -1.5 going to the left. Then we're going to do a check object. So the question is how you do a check object in GML. If we're trying to see if object is at a certain position. Let me look around a little bit. All right, so I think the function we want is instant place. What's odd about instant place is it doesn't return a boolean like a true or false. It returns a number that's either the instance ID or the keyword no one, meaning it's pointing to nothing. So the question is, how do we translate this into GML? Let's see. Let me get this out of the way. Doesn't seem to be a way to minimize it, so we have to go back here to our workspace. There we go. So if instance place, we're looking we'll say facing, for x we'll say facing times 16. It's 15, 16. And then for y, we're going to say 8. So we're looking up a little bit. And this is relative, so we have to actually add these numbers to the current x and y location of the jelly. So that's the equivalent of making, like hitting the relative checkbox in the drag and drop stuff, is you just add in the x and y directly. That makes it relative. And then we're looking for it not to be a collision with object platform. So basically it's trying to see if there's a platform beneath it. Maybe that's the question. So now that we've figured that out, we can write that in a comment. Is there a platform beneath the jelly? So here we say equal, because that will return an object idea of, or instance idea of object jelly, or object platform. So let's try just say object platform. I'm guessing. And we're trying to see if there's not a platform there. So we use this relational operator not equals instead of equals. Instead of the quality operator, we're using the inequality operator in this case. Let's make sure we have the right number of parentheses. Looks good. For every opening parenthesis, there should be a closed one. Let's see if we can make that error go away. It's complaining about something. Wonder what. Unexpected unary operator not equal to. So you need to be able to speak speak compilerese. It says not equals a unary operator. Well, in this case, it's not. I'm not using it as a unary operator. Unary means it's only takes one operand. Usually a relation operator takes 2. So I'm a little puzzled by this. Let me do some research. Yeah, so what I'm doing is misunderstanding how to write this. I think the way to do it would be you make object platform the third parameter going into instance place because it needs that. And then you would say, we're trying to see if there's not a platform there, so then you would put the not actually over here at the beginning. And we need one more parenthesis. Let's see if that makes it go away. Yeah, it does. All right. So that's what we want to say typically in English. Is there not a platform beneath the jelly? If there's not, then what do we want to do? I think we just want to make it turn around. Yeah. Because you reach the end of a ledge or something. And so we just invert facing. So we say facing equals negative facing. So obviously in math class that would make a lot of sense. Unless the variable facing equals 0, you could never say that this was equal. But this is not a math equation. This is an action. You're trying to set the value of facing to its opposite. So whatever facing is, if it's true, it becomes false, and if it's false, it becomes true. Or in this case, since it's not a Boolean, we have our values of 1 and -1. So facing is 1, it becomes -1, and if facing is -1, it becomes 1. So basically turns it around. We also have to do this kind of thing again. So I'm gonna copy this structure here. It's a control structure, it's called. And then the question is, what else do we have to check for? And we want the jelly to turn around if it runs into another hazard, so another monster or maybe a spiky thing or something like that. This time though, we're looking right horizontal to it instead of down under the ground. So it's a little bit different. And this time we're just looking for a more generic hazard. So we'll say object hazard. And instead of saying y plus 8, we just want to look at y the same level as the jelly. And then it's still facing times 16, so we're looking ahead of the jelly to see if there's a hazard there. And if that's the case, then we too want to change direction. Now it's complaining here. I'm wondering why. Object hazard. I spelled it incorrectly. See, if you put in a variable and the name doesn't match any other variables, it actually creates a new variable, which is terrible. You should have a formal declaration process, but the GML doesn't have that. So you get those errors every once in a while that are really hard to find just because you forgot to type a letter. Now we want to add a destroy event. So that's everything we need to do in the step event. Probably should have put a comment here just saying turn around if another hazard is in the way. Just say in English what you're trying to do in code. That's always helpful. So we're adding now a destroy event, and this is where we line up which sprite sequence we're going to use or animation sequence we're going to use when the jelly is dying, basically. So in the destroy events, when it's being destroyed, well, what do we want it to do? Well, we want to I'll convert this to GML. We want to set the global variable dot die sprite index. Remember, we created that one a few videos ago, I think, maybe the last video. And then we want to set that index equal to our jelly dying sprite jelly die there. This is when we finally identify which sprite animation we're going to use for the dying sequence. And we're storing that in a global variable, which is kind of kludgy. Probably shouldn't do it this way, but that's the way they're suggesting. And then when object enemy dies, goes through its destruction sequence, it will use this sprite to actually show the animation. Now, once we've set it, though, since we've overridden the destroy event, this will override the destroy event on the enemy object. And so for us to be able to continue destroying through the parent, we have to actually call the parent's destroy event. So question is, how do you do that in Gmail? So I'm going to say parent, see if that helps. Yeah, that seemed to work. So parent dot destroy. It's not giving us that option though. So I put in the dot. Now it's not helping me. Try that again. Parent dot. And we're looking for destroy. I don't see it. These are variables. So how do we call the parent objects? In Gmail. Let me find out. So here, I guess what we wanted to call is invent inherited. And yeah, that's what we want, that one. And that will call the parent's event. Looks like it liked it. That's good. Now over in Object Zool, we have this yeah, so we have to put in a collision event with object enemy. I don't think we've done that yet. So object Zool then. I find this kind of odd because I thought object enemy was a child of object hazard. Let's look at object enemy just to see. Object enemy, it doesn't have a parent. So I was thinking enemies were hazards, but it looks like enemies and hazards are two separate things. So we have to put in a separate collision event then with object Zool and object enemy. So let's do that. Here's object Zool. We add a collision event with object enemy. Here's a collision, hazards, object enemy. What do we want to do there? Well, we want to do the same thing we did with hazard. So here's hazard. So let me just maximize the screen, perhaps. And we'll just copy all of this. I don't know how to do that though. I'll do a select all. Control C, Control A, select all, Control C, and then switch back to object enemy. It's a collision event, right? So we're going back here. And reset my layout. Okay. Closes everything when you do that though. Reload. Object Zool. And then with collision with object enemy, we want to do all of this stuff that we copied. All the hurt stuff, the stuff we did in the last video where we jump in the air and we jump backward, it'd be the same as what we did with object hazard. Okay, so let's try putting some jellies in our room. I'm not really confident this is going to work because I don't remember giving. Well, the jellies do have a horizontal speed, so maybe it will work. Let's go to our room and see. I like to put jellies, maybe one roaming back and forth here. We haven't done ramps yet, though. So I'm going to zoom in here. We'll put a jelly right here. So let's see. Back to resources. Let's find our jelly object. Here's our jelly. We'll drag jelly out and put it right there. We need to be in the instances layer. That was odd. I didn't want to move the instances layer. See how it moved on me? You got to be really careful. This order means a lot. So you don't want to accidentally move it. And then drag this, and we'll put the jelly here. And the question is, how will that jelly behave? Let's try it in the game. Here's our game. We'll take a look at the jelly, see how it's behaving. That's weird. Our background is messed up. Oh no, I guess not. I just got the window kind of in a weird spot. So I click in the window, jump. Our jelly's spazzing out. But the actions of when we hit the jelly is doing pretty good. Took us a while to get that collision event, though. Yeah, so the collision with enemy seems to be working, but the jelly's movement's kind of messed up. So let's try to figure out why that is. Zoom out a bit here. Okay, so we'll go to the jelly object, and it's just its movement. It's kind of messed up. This would be in the step event. So one of these is failing. One of these tests. Not sure which one. And we could be calling the wrong function here too. I'm just kind of guessing. So let me double check that. Okay, so I think we're using the wrong function here. This don't think is going to work. I was a little bit skeptical when I first put this in because I was thinking, well, I think they need a instance ID there, and that's unique for every instance, and so that's not really going to help us any. So I think that what we want to do instead of instance place, we want to use this function called place meeting. Okay, it's kind of a funny term, but place meeting. It would take the same parameters though. So if the way it describes is with this function you can check a position for a collision with another instance or all instance of an object using a collision mask. Yeah, so it's checking for collisions is what we want. We want to see if something's over there. So instead of that, we'll just do place meeting instead. And again, we're trying to see if there's not something there. If there's not not a platform there, we turn around. If here, we kind of had this backwards, I guess, too. So we had two problems. We want to see if there is a hazard, then we do want to turn around. So I'm going to take that not off. Okay, so I think that should fix it. But I always say that. It never works. Let's try it again. All right, so take a look at the jelly. You see the jelly is now progressing, going back and forth. It turns around when it realizes that there's a hazard in the way. You see that spiky thing there? So it turns around when it hits the spike. So you can use the spikes to turn around the jellies if you want. But then the wall is as well. And the question is, why would that be? Because we didn't put a specific test for the wall. And the answer is, well, if you look at the design of the room, it's not the wall that's making it turn around. If we look at the room and let's go to our room, it's kind of sneaky the way it works. And we turn off one of the tile layers, that one. No, not that one. That one. We can see that see right there, there's no platform. And when the jelly gets there and sees that there's no platform there, it thinks it's at the edge of a platform and it turns around. So it's not the wall that's turning around the jelly, it's the platform not being there. So it's important when you do your room designs to leave out that block, I guess, or the jellies won't turn around, they'll just get stuck on the wall. It's important to leave that one blank. So I always wondered why they left that one blank. And I think that's because they wanted to show the end of the platform and get the jellies to move correctly. So now we have a reason why that seems to be empty. Okay, so we've reached our 25-minute time limit on these things. Let's see if we've done everything we need with the jellies. There's a couple of things we still need to do with the jellies, and that's creating enemy limits. Say you want to turn the jelly around, but you don't want to put a hazard there. There's these invisible enemy limits that you can place in that will act as a stopper and turn the bad guys around. And then we also have to deal with ramps. Ramps are hard for jellies because the jellies stick close to the ground, so we're going to have to deal with this problem. How does the jelly go up and down ramps? If we wanted to cop out, we could just say jellies don't go up and down ramps. So we have the sprites for it and we have the smarts for it, so we're gonna put that in. So maybe we do that in the next video, plus some other things. And then we'll be done with the jellies. All right, I'm gonna call it good.